We are on page 63, guys. If you have a question, it's on the board. Today we are moving on from fractional operations to area. The reason we did fractional operations first was because you will be using them in some of our areas. Not all of them have whole number size. Does that make sense? Okay, so before we move into the meat of the lesson, I want you to write 3 different numeric expressions to describe the total area of the rectangle shown. So let's discuss first. What is the difference between an expression and an equation? How do I know the difference? Which one has it? An equation has an equal sign and an answer. An expression does not. So that means you are simply writing a problem to represent how you would find the area of this rectangle. Does that make sense? All right, you have about 2 minutes to do that. Go for it. You're only writing 3 problems. All right, who can tell me one problem I can use to find the area of this rectangle? How many times 11? Who can tell me another one? 11 times 7. Who can tell me another one? Here? Yes, we can use the distributive property. We can break 11 into pieces. Remember we did that a few weeks ago where we broke them into pieces that were easier to multiply. Everybody remember that? Yep. I can also write 77, since that represents 77 times 1. Make sense? Good. Let's turn the page. Sorry, Max.
Okay, this one we're going to talk real quickly. When we are looking at, when we're talking about figures in mathematics, we have a whole series that we go through to name it according to the attributes that best describe what the figure is. So like for all of these, I could call all of these polygons, but that really doesn't tell you much, does it? No. So I try to use the most specific name for the figure that I can to give you a visualization of what exactly it looks like. So if I start on this first one, the one that's in kind of light blue, what would we call that shape? A rectangle. Why wouldn't I call it a square? Because the sides aren't even. So what are the attributes? In other words, what about that shape makes it a rectangle? Yeah. No, that gives me the measurement. But what about that shape makes it a rectangle? See? Okay, so the sides, I'm going to use that last, so you're right, the sides aren't equal. And there's 2 other characteristics to it that are really important. Yes? Okay, so it's not equal. The opposing sides are parallel. That's a really important part. And I'm going to put what you guys said, and we're going to put that together. Opposing sides are parallel and equal to each other. Actually, I'm going to say equal, but not the same.
That makes sense.
Because this is the same length as that, but it is not the same as this. Make sense? This side is the same as this side. The opposing sides are parallel, and they're equal to each other, but the 4 sides are not equal to each other. There's one other really important thing that makes it a rectangle. You did? Good. All right angles. Okay. So because of that, we know that the best terminology for this is a rectangle. It has all right angles. Opposing sides are parallel, but not equal, but not all equal to each other. Okay, what about our orange shape? What is that called? Triangle. Why? What makes that a triangle? Actually, could anybody be a little more specific?
The right side one?
The right triangle. Okay? So what are the attributes that make this a right triangle?
Oh,
Right?
it has a right angle.
Has one right angle? What else about a triangle? Okay, the three sides meet the quarters. When we're talking about shapes, we actually talk more about the sides than we do the corners. Okay, what about our pinkish shape? What do we call that one? No, parallelogram.
That could be rhombus.
Could that be a rhombus? Rhombus has all sides are the same.
Oh, really? It's a rhombus.
This one could be stretched as a diamond, but the diamond, the top and bottoms are the same. This one's not. You see that these sides are different shapes. They're different sizes, different lengths. Okay, so what else makes this a parallelogram? Good. Good. Opposing sides are parallel. Something else about the opposing sides. Yep. No. What else do we know about the opposing sides? Their length. Bigger. Right, they're equal. Are parallel and equal. But not the same. And that is the difference between a parallelogram and a rhombus. In a rhombus, all four sides are the same length. In a parallelogram, the sides are the same as each other, but they're not all the same. Okay? There's one other really important part in a parallelogram. In a rhombus, this line. So in a rhombus, if I were to cut it, this is 4. So if I cut it at a height of 4 here, this would be a rhombus.
Oh.
But then my sides are the same. A rhombus is a square without a right angle. Okay? So a rhombus is just a square, but it doesn't have right angles. It should give me a hint when I'm looking for a parallelogram. Well, it has acute and obtuse. The key is what it doesn't have. It doesn't have right angle. So there is no right angle. Okay? And then we get to our light purplish shape. What do we call that one? Yeah, okay. Trapezoid, good job. And what is your distinguishing characteristic for a trapezoid? Get like the same 3 people that are answering your question on it. Category. Jose? Not necessarily. Both sides could potentially be equal, but there's more important characteristics that make them trapezoid. Next. One side parallel. Okay, so you guys should have all of that written down, because that is how we distinguish our different shapes. It's kind of like a flow chart. You go through the flow chart, and you keep going until you can't answer any further. That tells you what level that is at. So, for example, on a parallelogram, I would go through and I'd say it doesn't have 4 sides. Yeah, that makes it a polygon or quadrilateral. Are the opposing sides parallel? Yes. Are both sides parallel? Yes. Are there any right angles? No. So I got all the way down to where it's parallelogram, but I didn't make it to where it's a rectangle. Because the next step after this is rectangle right now. I have 4 right angles. Okay? Questions on how we're naming any of these? Okay, so you do need to understand your distinguishing features for each shape. You good?
What about the square?
What about the square?
The square can't that be a rectangle type of thing?
Rectangle, and that's one of the interesting things. A square is a form of rectangle, but a rectangle will never be a square.
It makes sense. And is it one set of parallel sides or at least two?
No, if it only has one set of parallel sides, it's fabricated. Because when I get the 2 set of parallel sides, if both sides are parallel, then it's a parallelogram. And then when I get to where if both sides are parallel, but there's also right triangles, then it's a rectangle.
Right.
Yeah, right triangle. Or right angle, sorry. So when I get a 4-sided, opposing sides are parallel and there's right angles, now it's a rectangle. If I get to where all 4 sides are the same and it's all right angles, then it's a square. Make sense? Okay. Okay, so now that we've done that, each shaded figure has shown has an area of exactly 20 square units. Show how I know that. So if I look at it, if I look at this first one, this one would be the easiest because I can literally just count the squares, right? If I counted them, I would see this one goes 4 across, 5 tall. So you could count the squares. What in each figure?
I'm not sure.
Parallel means that they go side way that they'll never touch. So if I were to take this line and I extend it forever, those 2 lines will never touch in all eternity. Okay? And same on this side. If I extend those lines, they are never going to touch. Doesn't matter how long I draw them. Not parallel. So why? If I draw this and extend it, draw this and extend it, look. Now it intersects.
Triangle.
So the whole deal on the trapezoid, eventually they're going to touch because they're not parallel. On the other side, though, the other set, those are parallel, so those will never touch.
Okay.
So that's why we say 1 set of parallel lines.
Sides. That makes sense.
That make sense? Good question then. Okay. So that one was easy to see. What about this one? This one, I can kind of count some of the squares that are whole, right?
And then this one.
Well, look at this. What if I took this triangle and I flipped it upside down and redo it? What do I have then?
A rectangle.
Okay. How far is this? 4. I count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So on the rectangle, what would that be? 20. Triangle is the half of that rectangle.
20.
So my area would be
20. Mr. Moore sells for guys.
same on this one. She is. If I look at this distance, that's 4. And if I go from the bottom to the top of that, I go up 1, 2, 3, 4, 5. What do you see?
A rectangle.
20. Okay, we'll talk a little bit more on that in a second. On this one gets interesting. If I were to, and this one's kind of nice, it's got a good picture. But if I cut this piece off and I flip it over and put it in right here, what do you see then?
A rectangle. No, rectangle.
Okay? So, actually, I'm going to hand it over to Mr. Chan for a moment. Actually, go through definition.
All right, guys. We are not going to go to actually page 73 to do this. We're going to stay on this page, and we're just going to do it with our pencil, so we don't take up too much time. But first, let's look at the definition of parallelogram at the top of the page. A parallelogram is a four-sided figure with two pairs of parallel sides and opposite sides that are equal in length. Or highlight, either way. And a rectangle is a special type of parallelogram, as it has two sets of parallel sides. Does everybody understand? Yep. Okay. So if we look at the picture of the parallelograms on page 73, would it be easy for us to find the area when some of them cut through the boxes? Like some of them go through the middle of the boxes and don't take up the whole box. Would that be easy to find the area? No. So in order to find the area of a parallelogram, we can change it, but not take away any of the area. We can just rearrange it. So what if I cut off this rectangle and I moved it to this side? What did I make? I now made a rectangle, but did I add or take away any area from our shape? No, it is still the exact same as the parallelogram. I just moved part of it to a different place, and I have four right angles. Yes? All right, so who can tell me the formula for finding area of a rectangle or a parallelogram? Length times width, or somebody said height. What's the word that goes with height? Not width. Base times height. So we're going to label the base and the height of the parallelogram and the rectangle. So who can tell me where the base of my parallelogram is? Okay, I would say it's the bottom as well. Base means bottom, yes? Yeah. That won't always work. Sometimes your shapes are sideways or all kinds of different ways. But normally we say it's the bottom. So what makes the height of the parallelogram?
The opposite side of the
So this would be the height?
No.
No. The perpendicular side that makes a right angle with the base. So the two lines that make the right angle are our base and our height. Does that make sense? Your base and your height always have to make a right angle. And your height always has to be a straight line from top to bottom. It cannot be a diagonal line. That does not work. It has to be a straight line. Any questions about that? All right, where is the base on my rectangle? The bottom. And where is the height of my rectangle? The perpendicular side. And somebody actually used vocabulary over here. Good job. It is the one that makes the right angle with the base. Any questions? Does everybody know what perpendicular means? It means it makes that right angle. It makes a perfect corner. Make sense? All right, so that's how you know which one is the base and which one is the height, because they make that right angle. Yes. Yes. All right, let's look at the next page, guys. We are coming around to hand out your doodle notes. What? Oh, sorry, guys. I forgot the note at the bottom. Turn back to the last page real quick. The right angle symbol indicates that the lines or sides are perpendicular. They always make a perfect corner. I said it, I just didn't highlight it. All right, we're coming around to hand out your doodle notes.
Okay, so we've given you Google Notes on this. So remember, these can be used as a test. Please put your name on it. When you leave it somewhere, like have a chance to get back to you. So we've already talked a little bit about this, but when we are working with parallelograms and rectangles, the base and height must meet where? What did we just say is the key symbol to know where they're going to meet? Corner. So at the right angle.
Good copy, honey, copy.
So I know a lot of you guys consider math science numbers just suddenly magically appear and have meaning. Here's the one thing that makes areas super easy, guys. And building into that magic piece, I call it the magic box. So on all of your figures, you're going to have a magic box, right angle marker. Why is that magic? Because when I'm looking at a figure, that is going to tell me what's my base and what's my height. The two lines that touch that magic box are the two that you need to find area. So as long as you can focus in on that right angle marker, this should be a very easy exercise for you. Literally, all you're going to need to do is put the numbers into the formula. The key is finding the magic box. Okay? Why do I say that's the key? Because sometimes we have shapes like these. So we have three shapes here inside the circle. I want you to label the base and the height for each of these three quadrilaterals. I'll give you a hint. For some of them, you may need to draw an extra line if you don't have a magic box. Okay? You may work together at the table. You guys 3 minutes. And you can label the base and height on all three of them. Okay, on number one, that was a little tricky, right? You see the magic box?
Yeah.
There is one. So, on magic box, you get that perpendicular line. Somewhere like this. Which one is my base then? Bottom. I would call the bottom. If I got this on that one, it just makes sense. Base, that's the bottom. So now, where is my height? The one I just threw in, side. Okay? So this is my height here, guys. What do we call this line? We actually have a special math term for it. It comes to area. Now, that's not a mistake. It's part of the shape. Part of what makes that a parallelogram. Okay. No? Guys, you're not going to get it. I'll give it to you. It's called irrelevant. It doesn't matter. That is an important line for building the shape of the parallelogram. But when it comes to solving the problem for area, I don't care. So guess on a test, what the most likely thing you're going to see is? You're going to see that the test is going to send me a base of 6. It's going to put a line over here of 5. It's going to have a height of 4. What? I'm going to see 3 numbers. How many numbers do I need for my formula? 2. Area equals the base times the height.
Oh, so it's 30.
So it should be 24.
Oh.
6 times 4.
But
But
5 is.
so many of you are going to try to get that 5 into the problem some way. And it's totally wrong. I don't care about the 5. If I need perimeter, then I need the 5. If I'm finding area, the 5 is irrelevant. Which two lines are touching the magic box? Huh? Touching there. Those are the 2 lines I need. Four, 6, I need 4 to 5. Work longer than that, shorter than that. Write down, please. Okay, number 2. Regular interest on height. No. Why not? Because it's lopsided, right? Really weird angle. Missing something. What don't you see? Parallelograms box. So my first thing I have to draw in that perpendicular line from the box. Once I have the magic box, then you should be able to find your base. Sorry? I can do that. I told you that. Okay. When is my base along my height? When I have the magic box, I should use it. One would be base. Line is the height. I will say in a parallelogram, because my definition of height for a parallelogram is the perpendicular distance between the bases. So it has to be line. The base is the other one. Remember, shape number 3, the base fly shape, right? What shape is that? It already has a magic box. Draw it in. My base was the height. Shorter one is probably the base shorter. Okay. That is. Nobody else get that? Doesn't matter.
Oh.
Doesn't matter. Both sides are Any questions? Any questions on what we just did about all of identifying? I call that high order base. For number 3, number 1 and 2, it doesn't matter. Why number 1 and number 2? But on this one I had to draw it. Because the definition of height in a parallelogram is the perpendicular distance. It has to be straight. It's got to be a perpendicular line. Yes. This line on the outside, if I'm doing area, it's irrelevant. Formula is base height. My base and height are defined by the magic box. 2 lines are touching. So it's touching this bottom line, the 6, and touching the height line before that we had to draw in. Because for a parallelogram, your height is the perpendicular distance between the bases. So I need to know what that distance between those bases is. Along that side arm for area that's irrelevant. Okay? Asher? We're actually calculating now. We're about to do that though. Okay, so now we're going to try it. So I've given you a parallelogram. I've given you a base and a height. Do not forget your units. Karen, I messed this up last time. Put your answer in the box. Box there. The second part, to the point Ashley was making, this is where you get a chance. We're not actually going to get cut it. All we want to do is show how I would move this little piece here, turn this into a rectangle. Okay? So we got one problem to solve. This one, so we'll give you guys like 2 minutes. Guys, I did miss one. I apologize. We go back to the top. There was one I was supposed to work through together with you guys before we did it. So it gives this rectangle. The rectangle above has a length of 18 inches, a width of 11 inches. What is its area? So one thing I really like to do and highly encourage you to do is I always like to label it right on the picture. Nice thing that you guys all have your own books. You can write in them. Please take advantage of that. So in this case, it said the length is 18. So I'm going to call that my height. And I'm going to say that's 18 inches. It says that the width is 11. So I'm going to call that my base of 11 inches. We know that the formula for a rectangle is what? Area equals, technically it's length times width. That's why they did length and width. Okay? So if I use the numbers they gave me, my base or my length was 11 inches times my height or my width, 18 inches. 11 times 18 is going to give me, good job, Evan. So for those of you that didn't do that easily, let me try to explain what he probably did. He probably did it the same way I did. I took 10, 11, I said, okay, well that's 10 times 18, which is 180. And then I add another 18 to it, 198. And here's one of the most important pieces. Because we are dealing with data, I have inches times inches. How do I write that? Yeah. How do I write that? Inches times inches is?
Inches. With
Inches squared. Okay? We just did pi factorization, right? And I said if I had 2 times 2 times 3, how can I write that in exponential notation? 2 squared times 3. Correct? Well, now I have inches times inches. I can't really do inches times inches, can I? No. So I write it as inches squared. That's showing it's inches times inches. Does that make sense? Guys, here's why I'm making such a big point of this. You can do all of this work. You can get all of this, right? And if this is missing, you just missed half the credit. Half. That's still wrong. You have. Guys, you have to have the correct unit. Okay? Here's why. And I didn't go with this in last class, but now that we're in the area, I'm going to show you. Those look the same.
no.
Why? That's 1 inch. It's 1 inch long. This is 1 inch by 1 inch. This is 1 square inch. Those look the same. Look nothing alike. So if I say that my answer is 1 inch, this is what I'm saying. If I say it's 1 square inch, this is what I'm saying. Because that is different things. Yeah. So it is important to have the correct unit. Absolutely. It's a whole different concept. It's a whole different answer when you put a square by the unit. Is everybody clear on that? Whatever the unit is. And if they don't give you a unit, guess what I use?
Unit as your unit.
Square. So whatever the unit is, square. Okay? Guys, that is pretty important because it gives me a completely different picture of what my answer is talking about. Okay? So that being said, now you guys have already done these two. So again, this is a parallelogram. So I know that my area is base times height. What's my base? 5. So I can put it right on my finger. What's my height?
3.5.
3.5. Put it right on your finger. Guys, if you lay it on your finger, then it should be really easy to put it in the formula. Now I'm just going back to my formula. Base is 5 centimeters. Height is 3 5/10 centimeters. And now I just do the math. 3.5 times 5. You have to be 1 decimal. 25. 15, 17, but 1 decimal. So my area is 17 5/10 centimeters squared.
What?
Okay. Anyone once again, I put it in the wrong area. Formula. Here's my answer. Okay, our second part was to show it. Literally, all we wanted you to do is take this triangle and redraw it here, cut that out, and now what do you see? It's the whole concept. So, the reason your area formula for a rectangle so similar to a parallelogram is it's actually the same shape. All I'm doing is transferring this piece of triangle here from the perpendicular distance to the other side, and it will always match up exactly. How do I know that? Because those bases are parallel and equal. So it's the same distance, then whatever I'm cutting out, moving that same amount over to the side.
Very maybe like.
Everybody good?
Yes.
Yes.
My question is like, if you don't have the same units for the question that says 5 inches times 7, what is your units?
Awesome question. And that's one that they will use on tests. You have to convert them to the same before you can actually find the area. Normally, they're not going to go between metric and English unit. They'll do like inches and feet or feet and yards would be a really common one. But you have to go to the same units in order to calculate that area. Great question. Okay, let's go back into our books. Page 66. Now, just last class had so much issue on this. I do want to point out, compare the attributes of the parallelogram and the rectangle. They're talking about the ones you had just done on page 65. Okay? So it's referencing back to those two right there. And now I will turn the time over to Mr. Ken.
All right, guys, I will give you those questions on that page, 4 through 8, I believe. Sorry, 3 through 6. You have about 8 minutes to get these done. You may work as a table, and then we will come back and go through them. Thank you. All right. How does the height of the parallelogram relate to the height of the rectangle? And how does the length of the base of the parallelogram relate to the length of the base of the rectangle? So again, we were going back to this page and looking at the parallelogram we started with compared to the rectangle we made. What do we know about the height of the parallelogram related to the height of the rectangle?
They're both the same. That's right. No.
The height from top to bottom.
They're both the same height.
They're the same. They both have the same height. Stop it. What about the base of the parallelogram and the base of the rectangle? They're the same. Why are both of them the same? Abby? All we did was rearrange it. Did we add anything to it? No. Did we take anything away?
No.
No, we just rearranged part of it to make it easier to see. Yes? So they are the same. Not yet. All right, so again, they're the same. We did not add to or take away from the area. We only rearranged it. Make sense? All right. right, number 4, describe the relationship between the areas of the parallelogram and the rectangle since they have the same base and height. What do I know about the area? They have the same base and the same height. What does that mean? The area will be the same.
Yeah, but I have this written down now.
Area. All right, number 5. Use the terms base and height to describe how to calculate the area of a parallelogram. So what is our formula for area of a parallelogram? We did that on our doodle notes today. Not just base and height. What do? Base times height.
We still answer.
And that equals what? Area with units squared. Make sense? No. What doesn't make sense? Somebody said no. Who? Okay, what doesn't make sense? Would you rather ask Mr. Moore?
No, please don't.
What did she say? Guys, I don't know why you're yelling. We put units squared if we don't know if it's inches, feet, centimeters, meters. We always use units if we don't know what they are. And it's always squared. Got it? Yes, because that means time. 5. Guys, we're talking. All right, when you want to represent a quantity that varies or changes, you can use a variable. So I want you to get this vocabulary definition. A variable is a letter used to represent a number. So now we are throwing some alphabet into our math. You'll live. The use of variables helps you write formulas and express relationships. To write the formula to calculate the area of a parallelogram and a rectangle. We already did that. We used base for our B for our base and H for our height.
I thought you said there was no alphabet in mathematics.
Although I said we always have alphabet in mathematics.
We need to want to talk about it like alphabets.
We have words for alphabets, you know? 5. Next page, guys.
So we focus on getting away for extra time.
Yeah.
Yeah, our next one needs some explanation. We handed out a small piece of paper to you. Okay? On that small piece of paper, please listen. Here's what's going to happen. I'm going to show you. You won't be able to see it on the video because it's on top of the smartboard. But here's what we're going to do. Take your paper, put it directly over top of the shape. You're going to draw the shape, probably using a straight edge. I can't on the board. Okay? You're going to take your paper and you're going to flip it upside down. You're going to put those lines back together, just like this. And I'm going to then redraw the triangle again. And that's going to give you a shape.
That's weird.
Okay? You're going to do that for all 3 of those triangles.
Guys, talking.
And label the base and the height once you have finished that. Okay?
Okay.
So draw the shape, flip it upside down, put the lines together and retrace. About 4 minutes. We had to cut that short, but here's what's going to happen. When I drew this triangle triangle again. 4, so I go 1, 2, 3, 4. It should have looked something like that. On this one, when I flip this one up, that one should have been easy because it was right angle. This would have been the most difficult of the three. Okay? So if I do this one, and we draw it, now this base of 2 goes up here, and it comes down to the point. Okay. Quick side note. For those of you with your highlighter still out. When you're doing stuff like this, going to use a straight edge. Straight edge is the tool used to draw the line. A lot of times we call it rulers. That's the most common straight edge. But if we weren't recording, I would. But you gotta try to draw those lines straight. I can't on the board because the thing I put against the board is going to automatically draw. It also said label my base and my height. This should have been easy. There's my base. I don't have a right angle, so I need to make one, meaning that line would be my height. This one was easy. I have a base and a height. This is the most difficult. I need everybody to pay close attention on this. Okay? Here's my base. How long is my base? It's only 2. But to find a perpendicular line, I need to go all the way out to here to find my magic box, don't I? So I also have to extend this line over to get to the magic box. This part here is not part of my base. My base is still only 2 long. But once I get to that perpendicular line, now I can count. This height is now 5. I can now use my picture and count all of these. This base is 4. This height is 3. This base was 5. And the height was 4. Why is that important? Go to the next page. And here's where I got to cut you guys a little short. Determine the area of each parallelogram. So for number 1, I said the base was 4 and the height was 3. So that's going to be 4 times 3 or 12 units squared. For base 2, that one was easy because we counted all of them. That was 4 times 5 or 20 square units. For the third one, here's the tricky one. I said the base was base and height, and a base of 2, the height of 5, so it was 10 square units. Okay? Guys, here's why that last one was tricky. The first 2 should have been pretty simple, but remember, my base is only 2. When I had to draw to the magic box, this is not actually part of the figure. That's only to tell me where that perpendicular line is. Okay? Now, if I look at those, how does the area of each triangle relate to the area of those parallelograms? Well, how many triangles did I draw for each of those? 2. So, if I have the area of the parallelogram, what would the area of that triangle be? So the first one, parallelogram was 12 units. So what's the triangle going to be? Guys, this area, this whole thing is 12. What's this part? 6. Is that hard? Am I missing something? The second one, the whole thing was 20, so the triangle piece is going to be 10. So here's our last piece. Then you can go. What is our formula? 1/2 the base times the height, or you can write 2 formulas on this. Base times height divided by 2. Hey, hold on. Okay, guys, have a good day.